sig figs and scientific notations.
Alright, this video is on significant figures and scientific notation. When you guys are doing significant figures, pretty much what this means is which numbers actually matter, and this is based on how we measure it, like what instrument we use to measure it. Scientific notation is we're going to take those significant figures and we're going to write them in a way that is much easier to compare to other numbers so we can figure out the scale. Alright, so rules for significant figures and why do we do it? So significant figures, they tell us how to round a calculated value. Now when we calculate values or we measure values, we use instruments like this ruler. We can't have measurements that are more precise than the lines on this ruler, and that's where these significant figures come from. Now, we take our measurements, we make calculations with them, and we have to make sure that the output of a calculation is not more precise than the input that we put in. For example, if we measure that a circle's radius is measured to be 13.4 centimeters, notice that this is only to 1 decimal place. Its circumference, when we plug this into the circumference equation, we can't have this written as 2 decimal places. The instrument that we used to measure the radius of that circle was only as precise as 1 decimal place. This is more precise than we were able to measure, so we have to make a correction. We're going to put this as 84.2 centimeters. It's because our calculation cannot be more precise than our measurements. Now there's going to be 3 rules that we use when determining which numbers are significant. We have 3 different numbers right here, and these are going to demonstrate our 3 rules. Anything that we have, anytime we have a number that is not matching one of these 3 rules, it means that those numbers are not significant. Now we're pretty much figuring out which zeros we can eliminate from our number to make it a much shorter thing to write. It doesn't always come out really clean, but it usually works pretty well. Now our first rule is going to be that non-zero digits are always significant. If we look at this 1, 2, 3, 4, 5.6789, all of these are non-zeros. There aren't any zeros in this. So all of these are significant. We have 9 significant figures. Okay, rule number 2, any zeros between non-zero digits are significant. So these last 2 rules are going to tell us when our zeros are significant. So our zeros are significant if they're sandwiched in between 2 non-zero numbers. And then trailing zeros are only significant if there's a decimal place. So trailing zeros are significant if there's a decimal place anywhere. This page says if they're after the decimal place, that's not true. Anytime we have trailing zeros, even if they are not after the decimal place, those are significant. So trailing zeros. The reason that it says after is because they don't want you to confuse it with leading zeros, which we'll take a look at in a moment. So here's some examples of things that are not significant. So if I have 90210, I have a trailing 0 and there's no decimal. So I don't see any decimal at the end, meaning I do not include this 0 in my significant figures. I have 4 significant figures. I have a 0 that's sandwiched, which means that it is significant. The rest are all non-zeros. All of those non-zeros plus the sandwich 0 are significant. I get 4 sig figs. Okay, the next question, or the next example, I have 0.0090210. These are not trailing zeros. Remember, trailing zeros, if we have a decimal, those are significant. Leading zeros are not significant. So in this case, we do not include these first 3 zeros. We still include the 90210, and we have a trailing 0, but I have a decimal, so that is an okay sig fig. And I have a 0 that's sandwiched, so that is also a significant figure, giving us 5 sig figs. Okay, so for this one, I have non-zeros. The 9, 2, and 1 are non-zeros. Those are all significant. I have a decimal with a trailing 0. That makes this 0 significant. This 0 is sandwiched in between 2 non-zero numbers. All 5 of these are going to be significant digits. Now on this last one, we have 9021000. Trailing zeros with no decimal place means that those are not significant figures. We do not include those, and we have 4 sig figs. Anytime we are counting, or if we are trying to figure out how many students we have. Anytime we're counting, basically, is going to be everything is a significant figure. The next thing we're going to look at is scientific notation. How can we take these significant figures and use them as our way of writing large and small numbers in a more easily comprehensible form? Okay, so scientific notation is a method for expressing very large or very small numbers as the product of a decimal that's less than 10 and multiplied by a power of 10. So I'll show you a couple tricks on how to do this. You just have to remember that anytime we move our decimal place to the left, we are adding 1 to our exponent. Anytime we move our decimal place to the right, we're going to subtract 1 from our exponent. And what we want to do is we're going to take our significant figures and we're going to place the decimal point in between our first and second sig figs. So we want to place the decimal after our first sig fig.
Sig fig.
Figure. Okay. So we want to place the decimal after the first significant figure. All right, so let's look at a few examples. The first ones are going to be doing scientific notation, and then the second ones are going to be sig figs. Okay, so we want to convert the following into scientific notation. Remember, what we want to do first is figure out how many significant figures we have. We're going to take those sig figs. We're going to place the decimal after our first sig fig, and then we are going to place all of our other significant figures after the decimal and replace all of those zeros that we want to get rid of with an exponent of 10. So on A, I have 2 non-zero digits followed by trailing zeros. There's no decimal place, so I do not count those 5 zeros at the end. So I'm going to write down my significant figures. I have 9 and 8. I'm going to place a decimal after my first sig fig. And then I'm going to put times 10, and I want to figure out what my exponent is. Remember, anytime I move to the left, I'm adding 1 to this exponent. Anytime I move to the right, I'm subtracting 1 from this exponent. So I want to move it 1, 2, 3, 4, 5, 6 spaces. This is going to be 9.8 times 10 to the 6th. Now another way you're going to see, and another way that you're going to use throughout this course, is exponential notation. With exponential notation, it's another way of doing scientific notation. However, we replace this with a capital E. We typically use capital E, so it is not confused with Euler's number. You could use a lowercase e, but sometimes when you plug this into Desmos, it won't work because it will register that lowercase e as Euler's number, which is a constant that we have in mathematics. So the way that you will be writing this is typically going to be exponential notation would be 9.8. Now instead of times 10, I just put a capital E and then my exponent of 6. That represents the same thing. So all three of these are the exact same number. It's 9,800,000. And then if I put it in scientific notation, 9,800,000 is 9.8 times 10 to the 6. It's the same exact number, just written in 2 different ways. And then the exponential notation, we put 9.8 e to the 6, which still just means 9,800,000. Okay, so for our next question, I have leading zeros. Those are not significant. And then I have 3 non-zero digits. Those are significant. So my sig figs are going to be 6, 5, 4. I place my decimal after my first significant figure. Then I'm going to be multiplying this by a power of 10. I just need to figure out how many spaces I had to move that decimal. So I have to move my decimal 1, 2, 3, 4, 5 spaces. And that's to my right. So that means my exponent is going to be minus 5. Okay, exponential notation. I'm going to put 6.54 e to the negative 5. Okay, next question. I have trailing zeros. There is no decimal place, so those are not significant. I have 3 non-zero digits. Those are all significant. So I'm going to write down my sig figs. 7, 2, 3. I'm going to place my decimal after my first significant digit. And then I'm going to put my power of 10. Now I have to figure out how many spaces that I have to move it. I know that every comma is going to be 3 spaces. So this is 3, 6, 9, 12 spaces. So I have 7.23 times 10 to the 12th. In exponential notation, this is 7.23 e to the 12th. Remember, this is the same exact number every time. I'm just writing it in different ways. Okay, next question. I have leading zeros. Those are not significant. I have non-zero digits. Those are sig figs. So I'm going to write out my significant figures. 4, 5, 6, 3. I'm going to place my decimal after my first sig fig. Then I'm going to be multiplying this with the power of 10. I have to count how many spaces I move it. 1, 2, 3. So I moved it to the right. That's going to be -3. Exponential notation is going to be 4.563 e -3. Okay, last question. I have trailing zeros, but I do have a decimal, meaning that those trailing zeros are significant. I'm going to write down my significant figures. 6, 7, 0, 0.
6, 7.
Times 10 to the power of, let's see, I had to move 1, 2, 3 spaces. And then in exponential notation is going to be 6.700 e to the 3rd. Okay, so that is scientific notation. Let's do a recap of our sig figs just to make sure we understood everything. This will be our check for comprehension. If you want, take a moment, write down these numbers, try to answer it. Pause the video right here. Okay, so on our first question, we have leading zeros. Leading zeros are not significant. And then everything after I have a 0 that's sandwiched, that's significant. So I also have non-zero digits. This is going to be 4 significant figures. Next question, my 0 is sandwiched. That means it is significant. And this again is going to be 4 significant figures. Leading zeros are not significant. Trailing zeros are significant as long as I have the decimal place. So I am going to count 5 significant figures right here. Trailing zeros are significant. If there's a decimal, there is no decimal place here. So this would be 2 significant figures. So for this one, we have 2 sig figs. All right, anytime we have something in scientific notation, it's already giving us our significant figures. We have 2 significant figures for this question. Okay, next question. Leading zeros are not significant. Non-zero digits are significant. This is going to be 3 sig figs. Okay, next question. Again, this is already in scientific notation, meaning everything that I see right here is in significant figures. So I have 6 sig figs. Next question, I have trailing zeros and I have a decimal, meaning that those zeros are significant figures. I have 3 sig figs. Next question, I have a trailing 0 that is not significant because there is no decimal. The zeros that are in between non-zero digits are significant. So this tells me that I have 2, 5, 7 significant digits. All right, last question. We have trailing zeros, but there is a decimal place present, meaning all of those are significant. This is going to be 5 significant figures. Now, I'll show you one last time how to do scientific notation. We're going to take a look at C. And what we're going to do is identify our significant figures. We've already said there are 5. That's going to be these 5 numbers right here. I'm going to write those out. 70800 times 10 to some exponent. I want to count how many spaces I had to move it. I'm going to put my decimal after my first sig fig. I'm going to count how many spaces I had to move. 1, 2, 3, 4. And that is to the rightward direction. So that's going to be 10 to the negative 4. In exponential notation, this is going to be 7.0800 e to the negative 4. Now remember, scientific notation is just another way of writing our number. It's just one that we can compare to other numbers a lot quicker than trying to figure out how many spaces we are away from that decimal. We could just look at the exponent really fast and figure out what's a larger or smaller number. Sig fig.
No, I said every time that you say sig fig,
Sig
you
fig!
should say sig fig every time you say sig fig.